Hey everybody, welcome back. This is another lab walkthrough video. Today's lab is bond and molecular polarity. So like always, we're going to start off with our objectives. So we're going to use electronegativity values to determine the polarity of a bond, and then we're going to determine the polarity of a molecule by analyzing both molecular models and dot structures. So like always, we have background information that is super helpful. The front page is focusing on bond polarity. And so what we're going to do for bond polarity is look at the electronegativity differences. And with that, you need table S on your reference table. Now, once you have your electronegativity difference, you'll use this number line to determine the polarity of a bond. Now, your first step is to check what elements make up your bond pair. If you have nonmetals and nonmetals, you're going to have a covalent bond, but then you have to further distinguish between if it's nonpolar or polar covalent. So if your electronegativity value falls between 0 and 0.4, that is nonpolar, where something with 0 is your perfect nonpolar bond. And generally, Regents questions, when they ask you for a nonpolar covalent bond, they're looking for that perfect nonpolar. Then, if you still have nonmetals and nonmetals, and your range is between about 0.4 and about 0.7, that is polar covalent. Though there are nonmetal-nonmetal bond pairs with a number bigger than 0.7, so these cutoffs aren't exactly perfect. But again, nonmetals, that is your first thing, and then the larger the number, the more polar your bond is. Lastly, if you have metals and nonmetals, that automatically is ionic. There's no other types of ionics, but generally if you're looking at the electronegativity difference, you're going to have a number bigger than about 1.8. So you have this question here, which you can answer based on the number line and what we just talked about. This section, you're using table S to find the electronegativity values of both elements in a bond pair, calculating the bond electronegativity difference, or the bend, and then determining the type of bond. On the back, we are dealing now with molecular polarity, so you have a whole new set of background information focusing just on the polarity of the molecules. Again, you have very useful pictures and another acronym to help you remember what this means. Now, when you're using your models, different colors mean different things. So at your station, you'll have colored pencils to color coordinate everything that you have. So you're going to draw your dot structure and the model, the sketch of the model that you made with your model kits, whichever one is easier for you to do first, but you should be able to look at one and be able to identify the other. And based on that, again, you'll be able to determine the polarity of the molecule. So once you get to the back page of your lab, this is when you need the materials at your lab station. So you'll find a molecular model kit and you'll find a bunch of colored pencils. Now, when you open up your case, you have everything organized pretty nicely. You have all of your carbon pieces, all of your hydrogens. The colored ones are a bunch of different other elements. You have all of your connecting pieces. Now your job is to use all of these pieces to build all of the compounds on your lab sheet. Now, a few helpful tips. If you are dealing with single bonds, so you'll have to figure out the dot structure of your compound, so you'll know if you need a single bond or a double bond or a triple bond. Single bonds work well with the short pieces. Where double and triple bonds, you are going to need the longer, bendier pieces. You'll see why when you get into it. So you'll build all of your pieces, and you'll use your colored pencils to draw what your compound looks like. So all of your final molecules look like this. You have your H2, you have your O2, you have your HCl, you have your water, N2, NH3, your carbon dioxide, and your CH4. So once you have all of these, you'll draw them, and you can draw your dot structures as well to then determine the polarity of the molecule. Now, when you are all done, you'll break apart these compounds, just pop them off like this. Now, for the little pieces that can get kind of hard to take off, you can use your remover tool. So you just stick it in and then pop them off like that. So everything should go back very organized in your box. Put your sheet back on top, close the box, and leave the lab neater than you found it. At that point, that is the conclusion of the lab. Make sure, again, you unconnect all of your pieces and you leave the container better than you found it. That's this week's lab. Have fun.